shared on the chat. Once you click it, it will open this platform by default. You have to use this link, designated link. So if you just type RoboSim, then you may get a Chinese platform, because by default that's the language you'll get. But there is a dedicated link for international market. So you should be able to launch in English version. You can see the platform. RoboSim, the virtual robot, intelligent robot, innovation of AI, to facilitate STEM education, learn programming, and so on, so on. So once you get to this platform, okay, once you get here, the first thing you need to do is to click on login, okay. So login, it will open another section for account.robosim.com. Yes, so you can see we are on another platform, so move another subdomain, account.zmrobo.com. So now with this account, yes, it will be able to support you in RoboSim and also the IoT platform. I'll show you the IoT platform maybe later on for those who will be interested in MQTT and other advanced IoT for robotics. So yes, by default it's English, but you can always switch back to Chinese or any other language that you prefer. So you'll add your email address here. So for example, Jusin at afribot.africa. Once you add your email, then here, okay, sorry. For me, I'm already logged. I already have an account, so you'll proceed to register. You'll register. You'll put your email here, and then so for example, Jusin at afribot.africa, and then I click on next. So once I click on next, I'll receive how do you call it, a more verification email. They'll send me a verification code to more just check if this email is real. Then I'll get it on my email. You just log into your email and then you verify. Then when you during the time of verification, you will be required to create a password. Okay, so you create a password, then a password for your email account. Okay, then once you're done, you can now proceed and install. Alternatively, you can click on download as you do the other processes. So once you get here, kindly proceed to download. Then there are two versions of this. There is the campus edition and also the student and platform, the student edition. Campus assistant, for those who will be interested in using RoboSim to manage large classrooms, most often network computers, then you can proceed and use campus assistant. Okay, so I hope up to that point we are all together. Anyone with any question up to that point? No question. Okay, so I'd like to ask just one of the teachers. I can see I'm also checking our WhatsApp group. Feel free to feel free to send me a message on WhatsApp or just type on the group or use the in-call messages. I'd like to ask Miss Eunice, kindly share your screen so we help you complete the registration process and get started. Miss Eunice, if you are here, kindly.
Let me change from my phone to the computer first.
Okay. Okay, so as you do that, I wanted to share my experience with RoboSim. I've been using this platform for the last 5 years with learners, and RoboSim has really helped us to take STEM education to areas where they had to reach areas Also schools that don't have budget for the hardware equipment, that is robotics, because all you need is just the software and the curriculum to be able to teach robotics. Because the programming for this platform is the same as now the other physical robots. So we normally call this digital twin, because whatever happens on the virtual platform can also happen on the physical robots. Okay, so there are a few teachers who have also tried. Uh, there are a few teachers who have also tried RoboSim. I know Mr. Missy. Mr. Missy, Omar, have you tried it with your students as well?
Yes, I've actually tried it with my students, and as you are currently seeing here, I'm still having some of them. We are actually attending the meeting together. It is actually one of the best applications that one can actually use to actually teach robotics programming, just in case you don't have the physical robot, which are normally a little bit more expensive. So I think it's an opportunity that each and every educator should actually take advantage, especially when we are actually entering into CBC. So it's a competency that I think those who are actually going to grab it very fast, they are going to reap more, because that is where we are headed. It's a skill which we need to actually be teaching when we will be going to now the different career pathways when we will be joining the senior secondary school. Thank you. Back to you, Mr. Jusin.
Yeah, thank you so much, Mr. Omar. For those who are running the Kenyan curriculum, we just transitioned from 844 to CBC. Thank you for your comments. For other countries, I know competency-based curriculum will take form. Okay, will be introduced in other forms. International schools, yes, I like the curriculum as well. So if you're teaching an international school, this is also a good tool for you. As we wait for Eunice to share, allow me to share my screen as I launch my robot. Okay. I can see it's telling you. I need to telling me I need to connect to maybe a more stable internet. RoboSim requires internet connection when you are launching it, but after launching it, you can use it offline. So I forgot to tell you that. Mhm. Okay. So this is the home page for RoboSim. For those who are having issues with the language, you can always go to settings. Okay, settings. Let me also drop this on. Let me also drop this on the comment section because I know I saw such a question. So let me also drop it there. You can go to settings. Then once you are there, you can select your preferred language. So if I click on Chinese, everything else is changing to Chinese. If I click on English, everything else is back to English. Okay. Okay. So that kindly take note on how to change the language in case you're having an issue just go to settings and then account, then language. Okay, settings, account, language, then you are good to go. Okay. You can always choose when to update your RoboSIM as well. You can check updates. You can also seek for help. Okay. So you can also check which a mini icon for sending a direct email for support. Then on your top right corner, there is a button there, a very big button of a palette for school activities. Now, school activities is available for those who are using networked computers. Actually, these two, school activities and interactive classrooms, they're currently available for networked computers. So you can set up to 100 computers, network them, and get to control them from a single interface, courtesy of RoboSIM Campus Edition. Then we have the design. So design, as you know, after designing your robot, you want to have it move somewhere. Now you can come up with a theme with your students and create maybe a smart city. So a concept like smart city, you can always build here like the city, add different icons like trees, roads, the terrain. Okay, you can add buildings. You can add maybe residential somewhere, and then connect roads. Have roads that connect all this together, and yes, so and so on, so on. So it's a very, very interesting platform. I like using it so when I have pure access to the physical robot. Yeah, you can make it as complicated as possible. You can also align it with the theme of the term. So like international schools, they normally have like a termly theme. So you can always align it to that, design a map that suits that theme. Then once you've designed, you can save it. Then you share it with your learners to be able to use it. Okay, then on the bottom left corner, we have free build. So basically what free build does, it gives you like the robot pieces. Okay, so we have the RCU, which is the main robot controller. We have this. Okay, this is okay. These are pre-designed robot. So we have this is RCU. Okay, this is the RCU, the robot control unit. There are so many robot control units. They are from different manufacturers. There are those from VX, Lego, and so on, so on. So this is E6. If you have a physical version of E6, the design is on a scale of 1 to 1, the number of holes and everything, all the dimensions. So these are perfect digital twin of E6 RCU. Then the motors, you can see motors. Like this is utilizing two motors. There is a tire there. Oh, there is how do you call it? There is a camera. There's a camera there, and so on, so on. So you can always click on this icon just next to the search icon, and the first one will give you the different pre-built designs. You can choose type 2. Then we also have type 1 and type 3, type yeah. So now depending with the activity that you're having. So when you have a coding class and you don't want to waste a lot of time in designing a robot from ground up, one of the best ideas is to just pick it from here. Just pick a pre-designed robot and then use it for your classroom so you can focus on what's most important. Okay, so you should be able to join this meeting automatically. Sorry, for those who are using different accounts, kindly after the call share with me the account that you like to use for the call, so you don't have to request permission to join. It should always be automatic. Okay. Then we have connectors and other parts here. We have gears, different gears. We have sensors, the different sensors. We have as well the wheels and so on, so on. So I'll go back to the home page. I don't want to save this project. Then we do have training now, okay? So this training section, training section. Yeah, if you have a question, please feel free to reach out. You can send a message on the in-call messages. You can also WhatsApp. You can also use the WhatsApp channel or Telegram to raise your concern. So on teaching, we have by default, it will give you all the categories, that is teaching and training, super track, moon exploration and creativity. You can always explore these at your own time. So super track, most competitions are based on super track. Sorry, where robots are designed to follow some sort of line, and as they do that, they're supposed to accomplish some missions. Creative, these are based on stories. Like the younger students, they normally learn through play or stories. So you tell them a story like once upon a time they lived a lizard, and the lizard like to do ABCD, and one day this happened, and now design a robot to do task AB. Maybe design a robot to take the lizard to the mother, something like that. So creativity section is meant for creativity, just trying to combine STEM with the other aspect of learning. So you can see like this one, the forest is full of many dangers and it's necessary for Ming Ming, this animal to, sorry, I opened it quickly. Yes, then you're supposed to build a robot to take that creature from point A to the last point here, okay? Then it will, of course, it will be going with that robot. I'll go back, and I'll click back. And then for our class, we'll focus on teaching and training. Kindly explore the rest on your own for the interest of time. I'll also try to create as many tutorials as possible. To support many videos as possible this year, to support Africans who are using ROBOSIM platform. I'll use a blank space for today. I'll use a blank space. I hope we are all together. So feel free to do this with me, or you can just learn and then you do it later. So with a blank space, you realize that yes, I can see that icon that looks like a location icon. This means that once I launch my robot, it will start from that point. But again, if you look at this arm is for building. Okay, right now, even if I turn off my internet, I'll be able to use ROBOSIM. I just needed it to verify my account. If you look at, okay, this icon, we need to build our robot here. And building normally takes time. So I want to take a pre-built robot and just add a few things for us to move with speed. So I want to add a color lamp. So I'll go to sensors, I'll click this, and then I go to sensors and I choose colorful lights. Then this, I make it, I can put it at 90. That is okay. Then once there, I can always do this. I add some support, like 2 grids to support it. Then I pick it and I transfer it there, okay? These are color lamp. But again, a problem that you're likely to face, the reason why we're having this color lamp here is to help us know the state of the robot at any given time when debugging it. It's not a must. You can also use it to just communicate other things or just for beauty when performing missions. So for this case, I want to suspend it. I want to make it a little bit high. So I'll use the connectors. Okay, so I'll use that, and then I can see someone is waiting on the call. Just a second. Mr. Steven, I can see your hand is up. Kindly.
How do you navigate on the platform? On the platform, how do you?
Sorry. How do you?
How do you navigate the platform?
Okay. Sorry, I didn't hear you clearly.
How did you navigate to this point from the home?
Please, I was asking, how do you navigate the platform? I can see that you have been reporting
Thank you so much. Let me stop sharing my screen. Then I ask one of you to just share, and then we use that to learn. So who would like to share their screen? Kindly.
I would like to share.
Yes, please.
So can everybody see my screen, please?
Yes, you can.
Okay, just a second, if you can hear me.
What?
Hello, sorry, I can't hear anything. Okay, I think the network threw him out.
Can you hear me now? Hello, can you hear me
Yes,
now?
I can hear you now. Yes.
Oh, perfect. Thank you. Okay. Okay, let me see. You're sharing. Okay, yes, I can now see your screen.
Wake up, go off.
I'm trying to enhance that. Okay, I can see your present. Oh yes, I can now see your screen. Thank you. Yes. Now head to training. Click on training. Okay, perfect. Then teaching and training. Oh, perfect. Then click on blank space. Yes, so once you're there, then now you can navigate. You can navigate the three different options. There is that icon that looks like an industrial robot arm. Can you see it? Yes, that is for building. You can see if you hover around it, it tell you build robot. So you click it. Yes, now you have the design section. Then the next one is now called the robot. It looks like Scratch programming. Click it. So here is where now you program the robot. You can select this other side on the top right corner. You can choose the language that you prefer using, but for this session, for the introduction session, we'll just be using block, but you can always choose Python or C. Then the one that looks like building, yeah, you can always choose any language that or platform that you're comfortable with. The one that looks like besides it, the one that looks like building like flat. Can you see it? Just for simulation, and then there's one like icon. Yes, that is for debugging. Like if you want to debug the robot, so these will help you stop the robot at any given time, and even change the code if you want to. And then the last one, the last icon is start simulation. So if you don't mind, we can use your screen now to complete today's session. So let's just go back. So we move with everyone's pace. Then click on blank space once more. Then the robot arm for building. Okay, then take robot number 3. That one. Let's modify it a little bit. Go to add maybe 6 or 8 beam axis. Below the yellow one. Yes, that one. Add it. Click it. Just click on it. Did you click it? Okay. Oh.
Yes, I did.
Oh, there. Just drop it there by clicking it again. Okay, great. So let's look for connectors. Just scroll down. Scroll down there. The black one. Can you see the black one? No. The other side. Okay, you can take that double that double pin. That double pin will also work. Just above it, yes, to the left now. That is single pin. The left. No, that is right hand side to the left. The left, yes, that one, yes. Click it. Okay. Did you click it? You can delete this one. We don't need this one. We don't need this angle pin. Just delete it. Click it and then press the delete icon, the delete button on your keyboard. Yeah. Then the one just close to it, that one. Click it. Very good. So we are going to rotate it. So you right click your mouse. Very good. So make it upright. Use the red one. Make it 90 degrees, up to 90. Just continue adjusting. Until you see it at 90. No. There, 90. 90, there. Very good. Now drag it and put it and make it lock inside. No. Okay. Now, can you see where the buttons are on the side? The button on the robot, the powering button, and yes, just continue moving it upwards. Up a little bit. There are 3 holes. There are the last 3 holes.
Oh, okay. Oh,
There. Did it lock there?
no. Yeah.
Oh, did it lock really? No.
It did not.
I can see it's not at 90, so you'll be having a challenge. It's not at 90, so make it 90 first. Yes. Click it again. Okay. You can also.
Is it possible to type the angle?
Oh yes, you can type it. Very good. Okay. Try levelize your building area. Click on the building area. Let me show you something. Click on that building area. No. Just here, where can you see the wheels? The area surrounding the robot. The plate.
Yes, okay.
Yes, click on the plate and then right click your mouse. Okay. Long press the right button on the mouse and then navigate your mouse around. Try move your mouse around. Long press the right button. Yes. Now, okay. So try make it at around angle 90. You need to have a good clearance for the section you want to add this part.
You may need to take over.
Okay, let me check over then. Okay, no worries.
Okay.
Thank you.
Oh, yeah, the disadvantage of me taking over is now my speed. But no problem, I'll try be as slow as possible. Okay, so is my screen visible?
Not yet.
What about now?
Yeah, it's up. But you might need to start again, please. Maybe start from the beginning so that I can be able to follow too.
Oh, you can see my screen,
Yes.
Okay, perfect. Yeah, so mine already I've added. So you can always zoom. If you use the scroll button on your mouse, you can zoom in and out. Then if you long press the right button on the mouse, and then you move your mouse around, you can always change the view of your robot. So when building, okay. Then okay, so for mine I've already added this. Let me just remove everything. For my case, I used the small connector pins. Okay, I use the small connector pins. So I just took them here. Inserted the first one, inserted the second one, and then the grid. Then after the grid, I inserted another up here. Sorry. That's a bit out. I inserted another here and another there. Then the last one. Perfect. So I already have this robot. So if you are having a challenge with robot design, I can share with you my. Sorry, cancel. I can save this and share with you this design so you can use it. So say 1 million teachers robot design 1. Okay, so I'm sharing this robot design with you on the chat. Just a second. As a document. Okay. Yeah. So you'll find that on the WhatsApp chat. Okay, quick access. Okay. Okay. So that is already done. So I've shared on the chat. So you can just go to load local file. Okay. Load local file. Then you import it. So once you open that, you'll be able to import this design 1 million teachers. Okay. Then we can move to programming. So today I just want us to program this robot.
Before you continue,
yes, please. Yes.
How did you change the orientation of that arm? Maybe you go back there.
Here.
So,
orientation of this part.
Of this arm, yes, this arm. When you chose it, it was flat. So how did you make it vertical?
Oh, like this one, is it?
She's talking about the beam.
This beam. This one.
Yes.
Okay, so you can just right-click your mouse, okay, and then you use this. Right-click your mouse, and then you change the orientation. Then you can now drag it after changing the orientation. So again, before you insert it there, make sure wherever you are going to put it, you already have the pins to hold it there. This platform is running on a physics engine, so whenever it's not stable, it will always fall. So it will fall when you're doing your simulations.
Which angle did you use for the beam?
Okay, so I used around 0 degrees. So there is a blue arrow, a red, and a green one. So you need to know which direction you want to tilt. The X, the Z, or the Y. Okay. Then now you can always insert it there. Any question or anyone having a challenge? We are all good,
Okay, so I succeeded in changing the orientation, but the pins, where did you get the pins that you put in the holes before putting the pins?
Oh, okay. Yes, the pins are here. So you can there's a search bar. You can always search pins or connectors. Or alternatively, you can also, besides the search icon, there is this one. There is another icon that looks like a book. So you can click it, and then you have a library of pins to select from. So you have these two. You can search pin here, or you can always use the next icon. And then you scroll. You can scroll. You have the whole list here. So just use your mouse scroll wheel to get the right pin. Okay. We good up to that point? Any challenge so far?
I try to use the pins to search for the pins, but the pins I got in, maybe I don't know, maybe because this is not.
Okay. Kindly share your screen. No worries. Just share your screen. I assist you. Share your screen.
Okay. Okay. So I search for the pin. Is my screen up?
Not yet. I can't see it. Oh, you can see you've started presenting.
Can you see my screen now? Still not.
Yes, I can.
Hello, Justin. Are you still here? Hey. Hello, Justin. Are you still here? Hey, network.
I can see your screen.
Okay, so the question is, this pin, the pin has to enter this hole before I can invert this beam. So my question is, this is the only pin that I feel can be used. And this pin now, I think this is it now. If I should move it, and these are the available holes. You see that it cannot enter.
Okay. Oh, okay. You are using a blue one, eh? Oh, sorry. Kindly just delete that one. Yes. Use the black pin.
The black. There's only one.
No. You'll find it. Just delete that pin on your search bar. Can you see your search? Yeah. Use the next icon there. The one that looks like a book. Okay.
Okay. Oh.
Yeah, then there are pins there. There's a library of pins. No, the second last one. Second last. Oh, no. On the first row. The next right there. Click that. Click it.
Okay.
And then now check the one below it, the black one. Yes, that one. Yes. So you can use that one. Yes. You can decide to duplicate it or pick another one. Just pick another one. Make it. You can make them two to be more stable.
Okay.
Yeah. Again, I'll share manual for robot design, so you can practice this at your free time. You get to familiarize yourself with the different building parts and construct a robot maybe from ground up for practice.
Okay. Thank you.
Welcome.
Okay.
Most welcome. Then, you can change the orientation of this beam as well. Okay. Thank you so much. So I'll share my screen back. Are you able to see my screen?
It's running up.
You can now see it.
Yes, we can.
Perfect. So I'll move straight to programming. You don't have to make it this way. It doesn't have to be perfect. You can just take your color lamp and add it directly to. And just take it and add it directly to the robot on the side this way. For me, it's a little bit easy because I've been doing this over time. If you're doing this for the first time, it could be a little bit challenging, but over time it will be easier. Okay, so next I'll click this. and you can see my robot. My robot is already on the platform. My robot is already on the platform, and I can zoom, I can tilt it, I can view it with from whatever angle. So you can see my robot here. So next, I'll move to programming. Right now, even if I click to play, it will tell me there is no program. Please write the program first. So I'll proceed here and write the code. So when again, for those who attended our animation class, I got to explain the different blocks and parts. They are similar to Scratch, but I can take time a little bit to explain the different palettes and blocks, what they mean. So the RCU, so before you start your robot, or of course you need to declare the library that is involved. So here we'll be using the RCU library. This is more visible when you're using the other programming languages. For now, you can just say RCU task 1, for example. You also have controller time that you can play around with. You have inbuilt functionalities like the buzzer, that you can call the buzzer to be on. Maybe when you are you're negotiating a corner, to activate the buzzer for you to be able to know, yes, my robot has navigated the corner. Then you can reset the controller time maybe to 0. Then we have the motor. You can set motor. You can set the speed. You can also set the angle, speed at 40. Speed and angles. I hope you can see my screen. Yeah, so those are blocks under the motor palette. Then we have the sensor. We have the touch sensor P1, P2, and so on. You can check them out. You can interact with them later. And so on. Then we have AI pre-built libraries that you can get to use. So when now you are teaching your advanced students, or if you want to get deeper, hopefully we'll cover AI in our term 2 AI for robotics during term 2 training. Then we have the play. Of course, you can always load some MP3 file on the robot as well and get to play them. We have now the track card. This one is this is supposed to work with the 7-in-1 IR sensor. So there are like 7 channels, P1, P2, P3, up to P8. P8 minus P1, so you get 7 channels that you can get to utilize here. Then we have the move. This also works like the motor. This is like pre-built function as well. Like if you are using just 2 motors, you can always say, instead of creating your own function, you can say move forward, or you can create your own function from ground up. Show. This is meant to help you push some, maybe make something visible. So like if you had a variable and you want to display it on a screen, you can always decide to show that. Then we have the control. Again, how do you want this activity to happen, for when, for how long, and so on. Then we have operators, the different mathematical calculations, if you want to have them on this platform, or if you want to get some data and use that data to make decisions, of course, through programming. You can always do that. Then, there is a hand. Mr. Missy, I can see your hand is up. Yes, Mr. Missy, you have a question?
Sorry, your screen was not visible, but now it's actually visible. You can continue.
Maybe I can just stop presenting. Then I present. Just a second. Sorry for that. Okay. Can you see it now?
Let's give it seconds. Yes, it is now visible.
Okay, perfect. Thank you. So we have operators just the same way, same functionality with Scratch, just maybe having some arithmetics or comparing values on the during missions. Like for example, if there is a black line visible on sensor 1, no line on sensor 2, and an object on the ultrasonic sensor, maybe 10 centimeters. What do you need to do? Even how do you arrive at this is now 10 centimeters, and so on, so on. So you can always leverage on operators. Again, we'll use that. We'll use it during when we'll be designing complex robots. We have variables. The variables are just data containers. We had talked about this for those who attended the animation class. For those who did not, we'll create variables and use them to store some data. We have my blocks. Instead of repeating codes, you can always predefine codes. So you use how do you call it? So you use less lines to achieve to achieve complex missions just using my blocks. So my blocks again, they're like functions. Functions. So once you create a function, you have to define that function. Any question before I start programming our robot? Okay. No question. So I want to program this robot to move. Forward. Okay. So to move forward, anyone who would like to try apart from Mr. Missy? Mr. Missy, you'll come in later. Any teacher who would like to try on programming this robot to move forward? Which is the next block after when this robot starts?
The motor block.
Okay, motor block, I go to the motor block. Motor, thank you, and then, so we can say motor 1 and motor 2, okay? So, because we're using two motors, to get to know which one is motor 1, which one is motor 2, you can assign your motors here. See how your robot is appearing on the scene. Like our robot is facing this side, it's facing the park. So if I wanted this robot to face forward, I can decide to turn the map this way. That is number 1, okay? Or I can decide to change the orientation from the design, okay? I can decide to just change the orientation on the design this way. So that will change the direction of my robot. Again, if it's this way, then I'll need to know which one is motor 1, which one is motor 2. So I'll click it. So you can click on the motors, okay? Just click on the motors, and then on the left, on the right side, you'll get to see. So this is motor. So this is motor 1, okay, here. And then the other one, this is motor 2. Motor 1, motor 2. Okay. You can also assign them to other ports. This robot supports up to 4 motors. It has 4 designated motor ports. You can always connect it to motor 3 and so on, so on. But by default, it takes motor 1 and motor 2. So once I have that, then during coding, I'll have to come and say motor 1, motor 2 for it to move forward. Motor 1, motor 2, and then now simulation. I'll go to simulation and click that. So my robot will just move forward, as you can see, okay? my robot is moving forward, and it's not able to move any further. It's not able to move any further. So what do? I click on that, and then okay, yeah. So my robot is not intelligent up to this point. I don't have any sensors on board, but we can still hard code it. So we can tell it move forward for some time. So we go to control, and okay, move forward. Move forward for some time. So you can have this inside of forever, for example. Move forward, and then wait for maybe 1 minute. Okay. Sorry, 2 seconds, and then duplicate that, and then move reverse. Okay. So reverse again. You just add negative side on the speed. It will give you reverse. For some platforms, reverse, you need to just change. You can always change it here, forward or reverse. But for this platform, you just add a negative sign. It's direct. So when you'll be transitioning to other programming platforms, reverse is just negative sign. So negative 50 there. Okay. So once we have it, we can always go back and start our robot. You can see it's moving forward, reverse, forward, reverse, forward, reverse, forward, and reverse. Okay. So again, our robot is not intelligent, but we can always code it to do a few things for us. What if you wanted it to move in a question? Anyone with any questions so far? Any teacher with any question?
I think this scratch is application in this scratch so that I can be able to program the robot very well. So, and I missed this plan, so I have to just update myself on that. Thank you.
Oh, okay, thank you. I didn't get the first statements, but I'm able to connect the dots. We can also have just a WhatsApp call after this meeting to get to understand better. But I guess you're saying you need to understand the building aspect. So the building aspect, I'll share some resources that can also support you in building step by step. Then once you are able to build, then you are able to code. It will be easy for you to program the robot.
Okay, thank you.
Thank you so much. Yes, yes.
I've tried moving the robot backwards, but it's not moving back.
Okay. Are you able to share your screen?
Yes.
Thank you. Kindly proceed and share your screen.
Network yenu kanjanja bana.
my screen visible?
Yes. Okay. Let's just the problem. Can it? Oh, so your robot is moving and like ours,
Yeah.
Okay, stop simulation and let's work. Yeah, if you look at this activity that you want them to be repeated again and again. So from the wait 2 seconds, I can see this content is outside forever. So your code, your compiler reads up to the content inside forever. It's not able to break outside the forever block. So kindly detach that part and insert it inside the forever block. Insert inside. Inside there. Good. So let's go back. Simulate it. Is it moving back and forth?
Yes.
Thank you.
Okay. Also, another question.
Yes, please.
When building the robots, how do
Yes.
you know which part goes where?
Okay, yeah, so it's not a must. A part has to go to, for example, if you wanted to build a robot that it's a paper. So when building a gripper, again, the size of the hole, and the connector that you're using, they have to be compatible. For example, click on the connectors. Then you will find there's a blue connector, or just scroll down. Scroll down, I show you something. Okay, yeah. So let's look at that connector, the one that is highlighted already.
This one?
Yes. There's a pin, and then there's a blue one. Okay, that's a nut, because this end can connect one, and then the other end can connect two parts together. So now, depending with what you're building and the parts that you want to join, it's just like Lego, the Lego pieces. So each part has its own function, but I'll send you a PDF explaining the functions of all these parts.
Okay.
Describing the measurement, that is dimensions, and also the use scenarios when you need to use which pin or which part.
Thank you.
So after the call, thank you. Any other question? Okay. So are you using ROBOSIM on a tablet?
No, it's on a laptop. I've just split the screen so that I can be on the call.
Oh, okay. Thank you. Any other question from fellow educators? Okay, so I'll share my screen. In case you will have any question, feel free to just unmute your microphone and ask. I'll be glad to answer. Okay, so I'll proceed to making this robot now turn different directions. For example, turn left and right. Okay. Now, like if you're driving a car and you want to turn left or right, there's this component that we call differential. Differential, it works manual and automatic. Takes the path. The wheels normally take the paths with lower resistance. Okay, so if you want to turn, then assuming front wheel being more of a caster wheel that is not powered, and the power is on the wheels behind, on the wheels at the back. So I can stop one wheel and then make the other wheel move. So if I was to stop one wheel, then for me to move, for me to turn right, then that would be the right wheel. So I have to stop the right wheel to move to left wheel, then the right wheel will move towards left. That is just one of the methods of turning. So I want to know if any of you has any other method of turning. Also, even the toy cars, the toys that kids play with, when you want to ask that, anyone with any idea on how we can achieve turning left and right, besides stopping one wheel? Feel free to mute yourself. Okay, no worries. So you can always reduce the speed of one wheel as well. Okay, so you can reduce the speed of the inner wheel. So if you're turning right, you can reduce the speed of the right wheel, then increase the speed or maintain the speed of the left wheel, vice versa for turning left. The other alternative for turning is reversing the motors. So this is normally efficient when you are turning, when you are navigating sharp, when you are navigating sharp corners, reversing one motor and making the other move forward. So it's normally efficient for sharp corners or navigating sharp turns. So with that in mind, if we have this as negative 50, and this one as positive 50, this one has positive 50, how will it affect our robot or our code? I hope you are still able to see my screen.
Yes, yes.
So you can see, I've just negated the speed of one of the motors. You can see it's going in rounds. What if I did motor 1? Oh, that was motor 1. Sorry, I did this for just motor 1. So let me do the other one for motor 2. Motor 2. You can see it's turning left, turning right, turning left, turning right. Okay, so I'd like to know if there is any question up to that point. Before we close, next time we'll be meeting, we'll now learn how to use sensors. But of course, before our next meeting, I'll ensure I share with you some resources to help you learn. So next time, let me save that. Next time we'll be using, okay, do you want to save it? Not save. Next time we'll be using, we'll try out this ruler, and these are the challenge: ellipse and the circular space, how to follow lines with different sensors. There's also a square here. But if you have time, you can always do this on your own as well. I'd like to know if there is any question before we close today's session. Any teacher with any question? Yeah, so next time when we meet, we'll learn how to follow a line, how to follow a black line using sensors. So color sensors as well as photoelectric sensors. So sensors, if you want to try it on your own before the next class, you'll always find sensors here. You'll always find sensors. You click there and you find sensors here. So we have the photoelectric sensor, we have the color sensor, and the other touch sensors, and so on, ultrasonic, and so on. Yes, there's also a patrol card or 7-in-1 line following module. Okay, so allow me to stop sharing at that point. Let me know if there is any question.
Okay.
From the educators. Yes, kindly proceed.
Sorry, I have a question. Maybe I should just share my screen so that it will be so easy.
Okay, great. Kindly proceed. Yes.
Yeah, it is still on using the building the robot. Now, the other time we were talking about using pins, that the pins must be the right pin to be used, and I tried using this black pin. This is it here. So I tried to fix it here, but it's not working. So perhaps it's not the right pin.
Okay, kindly share. I'm not able to see your screen. Let me see.
Okay, let me know when it is off.
Okay, yes, I can see now you've started sharing.
Okay. So I was talking about the pin. To put this beam, I want to put the beam here so that, but before I can put the beam, I need to fix this pin. So I choose this black pin, just as you advised the other side, because it's in 2 grade cells. And this is the pin here. So I try to fix the pin here, but it's not staying. So what would be responsible for that?
Okay. Oh, okay. So the pin is not going through, eh?
Yes.
Okay. So if you look at the pin, it looks like there is something in between at the center. Okay. So.
Yes.
Try do the same thing. How are you doing it? Try drag it and put it there.
I just drag it here, and it's not entering.
So which pin is that? Try that.
It's a black pin here. This one.
Okay. Drag it. Then once you get there, you click it. You click your left mouse. Click your left mouse.
I clicked it.
The left side, yeah. Right.
Yes.
Left click the mouse. Left click to drop it.
I did. It's not working.
No, it should stop highlighting once you get there.
I think this is not working.
Mr. Willis?
I don't know what happened.
Excuse me, what
Can I
if she
assist?
tries
Yes, sorry. What if she tries?
turning the robot to the other side?
Yes, please try turn the robot.
Yeah, now she can fix it on this other side.
Yeah?
Can she try fixing it on this side so that you can see if it works?
Oh, yes, kindly.
It's still not working.
Can I assist Mr. Willis?
So I don't know.
No. Yes, please. Mr. Omar, kindly proceed.
Thank you. Though I can't actually see my screen clearly, it has just disappeared. But
Yes,
what
Mr. Omar.
I feel is that when there is a hole and then at the end of the hole there is a dead end, it's impossible for something to penetrate through. So when you're trying to that is put the pin inside, so there is the obstruction of the memory of the brain of the robot. Maybe what she can actually do is there is a pin which is actually above it. She can actually like use the one which is above. There is a pin which is actually above. I don't know whether you can hear me.
Yeah.
There is a black
Yeah,
pin.
on this beam.
No.
This one.
Not that one. There is the initial one that you are working on, just above the wheel. So there is the one which you have inserted. No, not that one. Not that one. There is another one that you have already inserted it. Try and remove it. The one which is above there.
It is not accepting any. I've not added any more. It is not accepting me. This is
there is okay. Can you look at the robot? Just the pins which are on the topmost part of the robot.
Yeah.
Not there.
Yeah.
No, behind the robot. Behind. Let's go behind. Yes. Yeah.
Okay.
Try and remove that.
This one.
No. Above.
Okay. Yeah.
There is no, just the one on the one which is close to your screen, close to your side. Not that one.
Okay.
The one in the robot. The one fixed in the robot. Yes, that one.
Okay.
No, there is a pin there.
Oh.
The black one, yeah.
Okay.
Yes, that one.
Okay. Also, I think I've seen the problem as well.
So I was saying there is a dead end. When you're trying to fix that pin and it cannot actually go, there is a dead end. That pin cannot actually go through.
Okay.
I don't know whether you have understood where the challenge was.
Yes, I can understand that now. But this place now, if you look at this view now, like this place now, this is an open space. This is an opening here. So I expect this plane to be able to enter into this second road here. I expect to be able to enter.
Okay. Let's do this. Try exit this page. Try exit the page.
Okay. I should stop sharing, right?
No. Just continue sharing. Try exit the page and do not save the file. Not save.
Okay.
Not save. Okay, and then open it. Launch the black space. Then let's proceed to building. Add the robot.